In this example, we're asked to solve the equation 2 to the x plus 1 equals 5 to the 1 minus 2x. Since the variable appears as the exponent of the two bases, 2 and 5, we know this is an exponential equation. And if we want to solve an exponential equation, we've got to remove that variable from the exponent. If possible, we know our first method to attempt would be to write both sides with the same base. But here we have a base of 2 and a base of 5, so we see that's not possible. So we're going to have to use logarithms. So if you want to just make a little note here, we can't write both sides with the same base. So we must use logs. Okay, so here, instead of using the definition of a logarithm, because we have a base on each side, that would be tricky. So here, we're going to just take log of both sides. So we're going to take log of 2 to the x plus 1 power, and that will equal log of 5 to the 1 minus 2x. So now the logs are equal. We have a rule that allows us to remove these exponents and multiply them out in front. And then that will remove our variables from the exponent so we can solve. So now we'll have x plus 1 times log 2, and make sure you remember the parentheses around x plus 1 because you don't just want to multiply the 1 times the log 2, it's the quantity x plus 1 times log 2. And we'll set that equal to the quantity 1 minus 2x, have to use parentheses there, times log 5. Now, we've got the variable on both sides of the equation, and the variable appears in parentheses. So if we're going to solve here and isolate the variable, we've got to remove those parentheses. So we'll distribute. So we want x times log 2, so that will give us x log 2, plus 1 times log 2, so plus log 2. And that will equal 1 times log 5, so log 5, and then times negative 2x. So minus 2x log 5. Now, all we need to do is get the terms that contain the variable on one side and the terms that don't contain the constants, on the other side. So we can either add the 2x log 5 to the left, or we could subtract the x log 2 to the right. So let's add the 2x log 5 to both sides to move it over to the left. So I'll have x log 2 plus 2x log 5, and then we're going to subtract the log 2 over to the right, so then we'll have log 5 minus log 2. So now all the terms that contain our variable are on the left, but now we know if we're going to solve and isolate x, we're going to have to only have one x appearing here on the left. So to do that, we can factor it out. So we'll factor out x. So if we divide x log 2 by x, we'll get log 2. And then if we divide 2x log 5 by x, we'll get 2 log 5. So now our final step to isolate x, we just divide by the quantity log 2 plus 2 log 5. So if I divide, that will give us log 5 minus log 2 over the quantity log 2 plus 2 log 5. So this is our exact answer. So you will probably be asked in your homework and on a quiz or a test for both the exact and the approximate answer to so many decimal places. So let's look on our calculator here. Now to evaluate this, this is a fraction with multiple terms in the numerator and multiple terms in the denominator. So we're going to have to group the terms in the numerator in parentheses and group the terms in the denominator in parentheses. So when we enter here, we're going to start with parentheses to enclose the log 5 minus log 2. So we want log 5. Now these parentheses, that's just around the 5. Now we'll subtract the log 2. Close those little parentheses. Now I close the parentheses around the entire numerator. There's my division bar. And now I need a new set of parentheses to enclose both terms in the denominator. So I want log 2 plus 2 log 5. And then I'll close those entire parentheses on the denominator and hit enter. And we get approximately 0.234. So just pay attention to how many decimal places my math lab or the quiz or test would like you to round. So then we've got approximately 0.234. And I will drag this screenshot into our notes here to remind us how to enter that. Now, if we wanted to check this answer graphically on our graphing calculator, remember we can graph our left and our right side of our equal sign here and see where those two graphs intersect. So we've got two exponential functions here, and we're going to see where they intersect. So we'll graph our left side. We want our 2 to the power. Now make sure you enclose in parentheses your exponent, x plus 1. And then our y2 would be the right side, which is 5 raised to the power. And again, make sure you enclose the 1 minus 2x in parentheses. So we'll graph. And there's our one ramp shape. And there's another ramp shape, and we can see that those intersect. We can zoom in, actually, if we want to see that a little more clearly. I'll zoom in, option 2, and hit enter. And we can see they certainly look like they intersect right here, which we're assuming we're looking for that to be about 0.234. So we can calculate that intersection point, second trace, calculate the intersection, option 5. So there, is this the first curve, 2 to the x plus 1? Yes, hit enter. Is this our second curve, 5 to the 1 minus 2x? Yes, hit enter. And hit enter one more time. And there's our 0.234, so we just verified our solution graphically.